All right, I thought I would do a video for you guys on how to do tonight's homework because we still are struggling a little bit with this. So we're writing the new function g, given the transformation asked to be performed on the function f, and we're going to simplify our final answers. F of x is x squared. We're first going to do a vertical stretch by a factor of 2. So we're going to write our function notation, f2 to f of x is our function notation. We take that, that means I multiply the whole function, x squared, by 2. And that's just 2x squared. The next step, it asks me, followed by a vertical translation up 5. So in function notation, that is f of x plus 5. So f of x is what I got from my first step, 2x squared, that's my f of x, plus 5. So that's just 2x squared plus 5. There's no simplifying to do. So that's the green step. And lastly, we need to do a reflection in the x-axis. So in function notation, this is negative f of x. That's our blue step. And that means I take negative times the whole function, 2x squared plus 5. So my final answer is negative 2x squared minus 5. And that's my final answer, which I'll box in red. Number 2, f of x is again x squared. The first thing it asks us to do is a horizontal stretch by a factor of 4. So in function notation, that is f of 1/4 x. Horizontal means it happens inside the parentheses, inside the function, and it also means it's the reciprocal of the factor. So instead of it being 4, it's 1/4. So that means I'm going to take 1/4 x and plug it in for the x. So it becomes 1/4 x squared. And when I simplify, I get 1/16 x squared. The next step says followed by a reflection in the y-axis. A reflection in the y-axis is f of negative x, 1/16. Plug in negative x for the x. So 1/16 parentheses negative x squared. Negative x squared is just x squared, so 1/16. I put that in the wrong spot. 1/16 x squared. And that's because we're centered at 0, 0, and when you reflect it around the x-axis, the y-axis, you can't tell a difference. The equation looks exactly the same. And then the last thing it asks us to do is a vertical translation down 4. So we're going to, let's put this in green, and f of x minus 4, which is our blue step. So that means I'm taking 1/16 x squared and subtracting 4. And that is my final answer, because there's nothing else to simplify. Now in number 3, my f of x is now x squared plus 5. The first thing I'm going to do is a vertical stretch by a factor of 2. So that's f of x, just like in problem number 1. But that looks a little bit different because I have more than just an x squared, so it's 2 times x squared plus 5, which is 2x squared plus 10. Don't forget to distribute the 2 to the 5. That's the most common mistake when you're doing a vertical shrink or stretch. The second thing it tells me to do, it says a reflection in the y-axis. So again, that is f of negative x plug that in, 2 times negative x squared plus 10, which is still 2x squared plus 10. And then the last step is a horizontal let's see. Let me highlight that, sorry. Horizontal translation left 3. Our function notation is f of x. Left is plus, because it's opposite, 3. That means I'm replacing the x with x plus 3. So it becomes 2 times x plus 3 squared. The x became parentheses x plus 3 plus 10. Now to simplify that, we need to FOIL out the x plus 3 squared, which is x squared plus 6x plus 9. Then we're going to multiply by the 2, 2x squared plus 12x plus 18 plus 10, which finally is 2x squared plus 12x plus 28. And that's your final simplified answer. And if you were asked for the vertex, like you were on the quiz, the vertex is -3, 10, because at this step right here, you're in vertex form. All right, let's look at number 4. F of x equals 2x squared plus 1. First thing, horizontal shrink by a factor of 1/3. A horizontal shrink by a factor of 1/3 in function notation is f of 3x. So there's your function notation, which means 2 times 3x squared plus 1. Simplify that, we do our exponent first, so that's 2 times 9x squared plus 1, which is 18x squared plus 1. Then we have a vertical translation up 4. So we go f of x plus 4 is our function notation, which is f of x is 18x squared plus 1 now, plus the 4, which is 18x squared plus 5. And then the last step is a reflection in the x-axis. So that's, negative f of x, which equals negative parentheses. I apologize, the video just messed up and popped that in there without me actually writing it. But reflection in the x-axis, negative f of x, which is negative parentheses 18x squared plus 5, which must distribute negative 18x squared minus 5. And that's your final answer. Number 5, f of x equals x plus 2 squared minus 7. Our first thing, horizontal translation, right 5. So right 5 is in function notation f of x minus 5. So we're going to be replacing the x inside the parentheses here with parentheses x minus 5. So that gives us parentheses parentheses x minus 5 plus 2 parentheses squared minus 7. There I replaced the x with the x minus 5. Now the parentheses are not so important here. I'm not distributing to anything. If there was a coefficient on the x, it would become extremely important. So that's x minus 3 squared minus 7. The next thing it wants me to do is vertically stretch by a factor of 2. So that's 2f of x, which is 2 times x minus 3 squared minus 7 in a bracket or parentheses, because the 2 distributes in front of the, and it distributes to the 7, in front of the parentheses and of the 7. So it's 2 parentheses x minus 3 squared minus 14. And then to simplify completely, that means I'm going to multiply out my x minus 3 squared. That's 2 times x squared minus 6x plus 9. I get that by foiling. We should be proficient with that because x minus 3 squared is x minus 3 times x minus 3. And then the minus 14 on the outside. So 2x squared minus 12x plus 18 minus 14, which gives me a final answer, 2x squared minus 12x plus 4. Okay, next on the back. I highly suggest at some point you pause this, give one of them a try, and then check your work. F of x is x squared plus 4. First step, a vertical shrink by a factor of 1/2. That's 1/2 times f of x. There's my function notation, which is 1/2 times x squared plus 4, which is 1/2 x squared plus 2. The next, reflection in the y-axis. F of negative x is a reflection in the y-axis. So that's 1/2 negative x squared plus 2, which is 1/2 x squared plus 2. And lastly, vertical transformation down 7. I meant for that to be blue. Vertical transformation down 7. So function notation is f of x minus 7. And that is 1/2 x squared plus 2 minus 7, 1/2 x squared minus 5 for our final answer. Number 7, vertical stretch by a factor of 3. That's not the right color. On x squared minus 1. So we have 3 f of x as our function notation. And that is 3 times the whole function, x squared minus 1, which is 3x squared minus 3. The next thing, reflection in the x-axis. So that's going to negative f of x, which means negative 3x squared minus 3. So that becomes negative 3x squared plus 3. The last thing it has for us here is to do a horizontal translation right 3. Function notation is f of x minus 3, which means negative 3 x minus 3 squared plus 3. We're going to multiply this out up here. Negative 3 x squared, x minus 3 squared is x squared minus 6x plus 9 plus the 3. Then I multiply negative 3x squared plus 18x minus 27 plus the 3, negative 3x squared plus 18x minus 24 is my final answer. And the last problem, f of x is x squared minus 4. Wants us to do a horizontal stretch by a factor of 3, which function notation is f, keep doing that, f of 1/3 x, which is 1/3 x squared minus 4. And followed by reflection in the y-axis, which is f of negative x, reflection in the y-axis on the inside. So, oops, I forgot to multiply that out. 1/9 x squared minus 4. So now I have 1/9 parentheses negative x squared minus 4, which is just 1/9 x squared minus 4. And then lastly, a vertical stretch factor of 2. Let's put this, it's my green. My vertical stretch by factor of 2 is 2f of x. And then that's 2 times 1/9 x squared minus 4, which is 2/9 x squared minus 8. There's your final answer. All right, guys, I hope this helped. We can go over the rest of the problems tomorrow in class.